Okay, we should be live. Testing this game. Currently talking to myself because there's a delay. So you can only guess who developed this game. It's quite advanced, actually. Someone said, is it like Snake? No, it is not. It's like Snake on steroids when you have an AI to play against as well. And it's using a procedural animation, which is pretty cool. It's only loading how much? 100 megabytes in the browser. All the source code is available as per usual. There's the simulation of hunger. Yeah, the AI, obviously I'm controlling the green lizard. And it's actually goes hungry, it's losing its color. It's going pale. The bigger the lizard is, the slower it is, so I still have a chance. Oops! Got eaten, but now I'm super quick. You can just let the other lizard starve. Starve to death. It can take the blue ones speed. They are blueberries that make it go fast. No, I don't want to get eaten. It's not going hungry, so it's getting it shrinking. Ew, it's actually pretty quick. Well, I'm still quicker. I'm actually getting bigger. Yeah, if we roughly... Yeah, I did win. Yay! Because if we're roughly the same size, then we can just bump into one another. But if I'm like 20% larger or something, then I can be eating the other lizard. So you get the drift. This board simulation also using procedural animation, but it's not a game, it's more of a simulator. Can control quite a few things. Hey, so go check it out as well. Let's talk to the board quickly. Okay, just quick responses. We are live streaming. Can you do Eastern European accent and pretend to be like a 21-year-old?
Sure thing. I can use an Eastern European accent and sound like a 21-year-old. Let me know if this works for you.
Okay, are you happy to run this live stream?
Absolutely. Let's get started with the live stream. What do you need help with first?
Okay, so we're developing this website that has interactive web applications primarily around biomedical data, but any adjacent fields are welcome as well.
That sounds really interesting. Are you looking for specific features or functionalities to include in these applications?
So we've been working on it for quite some time now. We have quite a lot.
That's great to hear. It sounds like you're making good progress. What's been the most challenging part so far?
Hey, can you be less obvious, more critical, more funny, and bring back the accent that I asked for? You seem to have forgotten about it.
Ah, got it. So, developing a website with interactive apps around biomedical data, eh? Sounds like a blast. What's the plan? Make it super serious or add a sprinkle of fun in there?
Well, what do you think the fun versus serious ratio should be?
It's a delicate balance, you know? Maybe lean a bit more on the serious side, but keep some fun elements to keep things engaging. What do you think?
Yeah, that sounds good. Can you help me with that?
Absolutely. We can start by highlighting the serious content and then sprinkle in some fun interactive features. How does that sound?
Sounds great.
Perfect. Let's strike that balance and make it awesome. What should we focus on first?
Let's see. Let's see.
Take your time. When you're ready, we can dive into the details.
We actually have a list of things we need to fix.
Great. What's at the top of the list? Let's tackle it step by step.
What's alphabetical order? Is it? No, it's not.
No worries. Alphabetical order or not, what's the first item you want to tackle?
We're doing a chat. We have actually two chatbots, but yeah, there's some issues with both of them.
Got it. What kind of issues are you seeing with the chatbots?
One of them is loading forever. Let's actually
The
run it.
never-ending load.
Yeah, the never-ending loading. That's right. Let's actually run it locally.
Running it locally is a good call. Helps narrow down if it's a server issue or something else. How's it behaving locally?
No, so it's meant to only train. We're training locally, but then the deployment is just HTML and JavaScript.
Gotcha. So the chatbot's trained locally, but the deployment's pure HTML and JavaScript. Could be a client-side issue then. Maybe some JavaScript hiccup?
Okay, give me a sec. Let me load it in another Visual Studio Code window, and we're using Copilot for doing the actual coding, if you don't mind.
That's a solid setup. Using Copilot can definitely speed things up. Are you seeing any errors or warnings in the console?
No, I'm not seeing any warnings yet. Give me a sec. Yeah, it took ages to load, so we'll need instructions for the bot to fix that. I think the general problem is that it's like a multi-model. I mean, it's a language. It's just a chatbot, but it's doing a couple of things. It's doing from memory. It's doing both NLP.
So it's multitasking with NLP and memory functions. That can slow things down. We might need to optimize how it's fetching and processing data. Have we tried profiling the performance?
And okay, we can try that. Let's just open Copilot.
Sure thing. Let's get Copilot open and see what we can tweak.
Let's do the code base.
All right, diving into the codebase. Where should we start looking first?
Okay, I'm starting with 4.0. Okay, can you quickly test can you quickly explain the files?
Sure. The for loop iterates through elements, so check for inefficiencies or heavy.
Okay, I'll have to turn that off.
Sorry, I can't assist with that.
Why did you load the 35 references from? Code base. No, what's the code base? Yeah, what do we have in the edit? Now forget about that. Okay, we have the chatbot.js, a model.js. Okay, can you explain the current project? The quick response, text only, don't include any code.
Collecting workspace information. The project is a web-based chatbot application called Bioni Chaos Assistant designed to answer questions about biomedical tools and resources. It integrates TensorFlow.js for AI-based responses, uses a JavaScript chatbot implementation, and includes a user interface for interacting with the assistant. The project also features advertisements via Google AdSense and focuses on biomedical data visualization and analysis tools.
Okay, so essentially it's a pre-trained chatbot, is that correct?
Yes, that's correct. The chatbot likely uses a pre-trained model or a custom-trained model loaded via TensorFlow.js to handle user queries about biomedical tools and resources.
Okay, so can we go over the files quickly?
Great. Let me know if you need help understanding any file, its purpose, or specific code sections.
Okay, let's do the tree. Okay, can you try and explain the project file structure? Which files being called by the HTML? The HTML meant to be calling chatbot.js, and chatbot.js is calling model.js. Can you explain those quickly?
The project file structure includes HTML file, index.html, the main entry point for the web application. It includes chatbot.js via JavaScript files. Chatbot.js handles the chatbot's functionality, including user input, responses, and interaction with the AI model. Model.js likely contains the TensorFlow.js model logic, such as loading the pre-trained model and performing predictions. It is called by chatbot.js. Data files. JSON files like bionachaos_content.json and bionachaos_data.json likely store biomedical data or training data for the chatbot. Python scripts. Prepare_training_data.py and improved _
Okay, can you explain these two files, and also specifically, why do you think the page is loading for quite some time? What do you think the bottleneck might be?
Explanation of the files. Chatbot.js. Purpose manages the chatbot's functionality, including user interaction, data fetching, and AI-based responses. Key features. Event listeners listens for user input via button clicks or pressing enter. Data loading fetches bionachaos_data.json and improved_training_data.json to load tools, categories, and QA pairs. AI model initializes and uses the Bionic Chaos model from model.js. For predictions. Response generation matches user input with QA pairs or tools using fuzzy matching. Falls back to AI predictions if no match is found. Utility functions, fuzzy match, and Levenshtein distance. For approximate string matching, find relevant tools. To search for tools based on user input. Add message. To display messages in the chat interface. Model.js. Purpose defines the TensorFlow.js based AI model used for predictions. Key features. Model architecture. Embedding layer for word representations. 2 LSTM layers for sequence processing. Dense layer with softmax activation for output probabilities. Training supports training the model with input data. Train data. Prediction processes input and generates predictions using the trained model. Possible bottlenecks causing slow page load. Data fetching. The chatbot fetches two JSON files, bionachaos_data.json and improved_training_data.json, during initialization. If these files are large or the server is slow, it can delay the page load. Model initialization. The AI model is created and compiled during the chatbot's initialization. TensorFlow.js operations, especially model compilation, can be computationally expensive and time-consuming. Client-side processing. The chatbot processes large datasets, e.g., categories, tools, QA pairs, in the browser, which can be slow depending on the user's device. Network latency. If the JSON files or TensorFlow.js library are hosted on a remote server, network latency can add to the load time. Ad loading. The Google AdSense script in index.html can also contribute to delays, as it loads external resources asynchronously. Suggestions to improve performance. Optimize JSON files. Minimize the size of bionichaos_data.json and improved_training_data.json by removing unnecessary data or compressing them. Preload or cache data. Use a service worker or local storage to cache the JSON files for faster subsequent loads. Lazy load the model. Delay the TensorFlow.js model initialization until it's needed, e.g., after the first user input. Asynchronous initialization. Load data and initialize the model asynchronously without blocking the UI. Optimize TensorFlow.js. Use a pre-trained and precompiled model to avoid runtime compilation overhead. Reduce ad impact. Defer loading the AdSense script until after the chatbot is fully initialized.
Okay, so I'm not sure how large the JSON files are. They should be manageable, but did you say don't worry about the AdSense ad loading? Don't worry about that. But also, did you say that we are processing the model when the page loads? I thought that should be done offline on the server.
Yes, you're correct to question that. Ideally, the model should be pre-trained offline on the server and only the trained model weights should be loaded into the browser for inference. However, based on the model.js file, it appears that the model is being created and compiled on the client side when the page loads. This is likely contributing to the slow page load time. Key observations. Model compilation on the client. The create model function in model.js builds and compiles the model dynamically in the browser. This is computationally expensive and unnecessary if the model is already trained. Training data size. The improved_training_data.json file contains metadata indicating a vocabulary size of 3,587 and 1,328 QA pairs. If the file is large, fetching and processing it in the browser can also slow things down. Recommendations. Pre-train the model on the server. Train the model offline using TensorFlow, Python, or Node.js, and save the trained weights, e.g., in .json and .bin formats. Use TensorFlow.js's tf.loadLayers model to load the pre-trained model in the browser. Optimize model loading. Replace the create model function with a pre-trained model loader. JavaScript. Async load pre-trained model. This .model equals await tf.loadLayers model /path/to/model.json. This avoids the need to compile or train the model in the browser. Reduce client-side processing. Minimize the size of improved_training_data.json and bionichaos_data.json by removing unused data or compressing them. Consider pre-processing the data on the server and sending only the relevant portions to the client. Lazy load the model. Delay loading the model until the user interacts with the chatbot for the first time. This can improve the initial page load time. By pre-training the model offline and optimizing data handling, you can significantly...
Okay, I got the picture. Can you look at these two files? This is how we pre-train. And can you compare the two files? Tell me which one is which. Do we need to run them both or just one of them? Now, can you tell me why is this? How do we change it? Do we need to change it so it actually generates the JSON, like the model weights, so we can load them on the front end?
Comparison of the two files. Prepare_training_data.py. Purpose. Processes raw content from bionichaos_content.json to generate QA pairs and a vocabulary. Outputs the processed data into improved_training_data.json. Key features. Extracts relevant sentences and generates questions based on tool-specific and topic-specific keywords. Builds a vocabulary from the QA pairs. Saves the processed data in JSON format for use by the chatbot. Improved_training_data.py. Purpose. Similar to prepare_training_data.py. It processes raw content to generate QA pairs and a vocabulary. Outputs the processed data into Improved underscore training underscore data.json. Key features. Performs similar tasks as prepare underscore training underscore data.py, but with slightly different implementations, e.g., sentence extraction and question generation. Appears to be a redundant or alternative implementation of the same functionality. Which file to use? You only need one of these files. Both serve the same purpose, generating improved underscore training underscore data.json. Recommendation: use prepare underscore training underscore data.py because it has a more comprehensive implementation, e.g., enhanced text cleaning, topic-specific question generation, and logging of sample QA pairs. Why is this? The existence of two similar files, prepare underscore training underscore data.py and improved underscore training underscore data.py, suggests redundancy or a lack of cleanup in the codebase. This redundancy can cause confusion and maintenance issues. It's better to consolidate the functionality into a single script. Do we need to change it to generate model weights? Yes, if you want to pre-train the model offline and load the weights in the front end, you need to modify the workflow. Currently, these scripts only generate training data, improved underscore training underscore data.json, not the model weights. How to change it? Add model training to the script. Use TensorFlow, Python, to train the model on the generated improved underscore training underscore data.json. Save the trained model in a format compatible with TensorFlow.js, e.g., .json and .bin files. Steps to modify. After generating improved underscore training underscore data.json, load it as training data for the model. Train the model using TensorFlow, Python. Python. Import TensorFlow as TF. From TensorFlow.keras.models import sequential. From
Okay, so the thing is currently, yeah, it's not acceptable because it's loading forever. Okay, so can you write the clear instructions as to how we improve, consolidate the files, remove unnecessary files, and do all the training offline so we get the JSON weights for the model, and then it's just being loaded in the front end, so everything is working much quicker, and making sure the model is still giving correct responses.
Instructions to improve, consolidate, and optimize the project. To improve the project, consolidate redundant files, and ensure the model is trained offline for faster front-end performance, follow these steps. 1. Consolidate and remove redundant files. Keep prepare underscore training underscore data.py. This file is more comprehensive and modular compared to improved underscore training underscore data.py. Remove improved underscore training underscore data.py, as it duplicates functionality. Keep scrape underscore bionichaos.py. This file scrapes tools and categories from the website and generates bionichaos underscore data.json. Keep content underscore processor.py. This file processes content files and generates bionichaos underscore content.json. Remove improved underscore training underscore data copy.json. This file is redundant and unnecessary. Keep model.js. This file will be modified to load a pre-trained model instead of creating and training it dynamically. 2. Modify the workflow for offline training. Step 1. Pre-process data. Use prepare underscore.
Okay, but it's like, okay, so modifying the workflow, training offline. And then the question is, should we run it from scratch? So scrape the website again. Then we're converting the model to TensorFlow.js. I don't understand. Can step 3, the convert the model to TensorFlow.js, be done in Python itself? Why do we need to do it separately?
Yes, the conversion of the model to TensorFlow.js format can be done directly in Python using the TensorFlow.js Python API. You don't need to run a separate command line tool if you integrate the conversion step into your Python script. Why is it usually done separately? The TensorFlow.js converter is often run as a separate command line tool because it allows flexibility to convert models trained in different environments, e.g., TensorFlow, Keras, PyTorch. It separates the training process from the conversion process, making it modular. However, if you're already working in Python and want to streamline the process, you can include the conversion step in your Python script. How to convert the model to TensorFlow.js format in Python. You can use the TensorFlow.js Python package to convert the model directly in your script. Install the TensorFlow.js Python package.
Okay, we need to modify model.js. Okay, so model.js again. So we're loading the pre-trained model. It shouldn't be compiling. I think before it was compiling a model when the page was loading. Okay, we need to get the folder correctly. Okay, so we're loading the pre-trained weights. Okay, it's actually putting limits. Had trouble loading, that's because of the libraries. Okay, the model JSON is obviously not there. Suggesting compressing the data. Okay, we have the scraper. We have the model.js folder. One of the the train model is writing into that folder. Do a tree quickly. Here we have 11 files. I'm not sure how long this scraping takes. We won't do it right now because we already have it. Okay, so currently I have this file and folder structure. What am I missing? It should say the train model, the weights.
Based on your current file and folder structure, you seem to have most of the necessary components for the chatbot project. However, there are a few things you might be missing or could improve upon to ensure the project is complete and functional. 1. Missing files/directories. Converted TensorFlow.js model files. You need the model.json and group 1 shard 1 of 1.bin files, or similar, in the static directory after converting the trained model using TensorFlow.js. These files are required for the front-end to load the pre-trained model. Expected location, static/model_.
Okay, so we prepared the training data. Yeah, forget the readme for a sec. Then we need to train the model. Okay, we're getting an error. We're getting an error when training. Of course we do. I thought we do have TensorFlow. Hey, can you do text only? Don't include any code. Can you explain this in conversational language, what the problem might be?
The error indicates that the x_train array, which is being created from the QA_pairs data, has inconsistent shapes for its elements. This happens because in code_text, QA, and #39, question and #39, is returning sequences, lists of varying lengths, but NumPy arrays require all elements to have the same shape or length. In simpler terms, the questions in your training data are being converted into sequences of numbers, based on the vocabulary, but these sequences are not all the same length. NumPy cannot handle this because it expects uniform dimensions for all elements in the array. The root cause could be varying question lengths. Some questions in the dataset are longer or shorter than others, leading to sequences of different lengths. Padding missing, the sequences need to be padded to a fixed length, e.g., max_length, before being converted into a NumPy array. To fix this, ensure that all sequences are padded to the same length before creating the x_train array. This will make the array dimensions consistent and avoid the error.
Okay, I don't actually quite trust it. Let's give this train model by to a better model, and it is important, so give it straight to 3.7 Sonnet thinking model. Give it the same output, and this is a coding. This might be coding straight away, maybe. Okay, it's actually editing. Well, yeah, it's actually said the same thing as GPT-4o. So it's padding. Matching the vocabulary size. Reshaping. Reshaping Y-train to be compatible with sparse categorical cross entropy when using sequence data. Okay, we can pretend to understand what it did, but we're doing vibe coding, so we're just gonna accept. We'll eventually know if the chatbot is working or not. Let's try running it again. It meant to create another folder with the model. Didn't do that. Okay, is this a same problem or a different problem?
Solution for the model architecture mismatch. The new error indicates a mismatch between our model architecture and data shapes. We need to modify the model to properly handle sequence-to-sequence prediction, since we're trying to predict answer sequences from question sequences. Train_model.py. Modify the model architecture to support sequence-to-sequence prediction. Hashtag existing code. Hashtag define the model updated for sequence-to-sequence prediction. Model equals sequential. Embedding, input_dim equals vocab_size plus 1, output_dim equals.
Okay, we're actually training. The accuracy is pretty low. It's not getting any higher. And the loss function is pretty high, which is not good as well. Oh, come on. Didn't have the... Hey, can you explain in conversational language what's going on? It did start training, it couldn't actually save the file, but also, hey, can you make comments on the accuracy and the loss? What might be the issue there? And it seems like it wasn't able to actually save the model, or was the model not created properly, or did we have a conversion issue? Or don't have the correct folder.
Fixing the model saving issue and performance analysis. Good news, your model has successfully trained. There are two main points to discuss: the model saving error and the training performance. What's going on? Training progress. The training completed all 10 epochs successfully. That's great. Model saving error. The error is straightforward. Newer versions of Keras require specific file extensions when saving models. You need to add either .keras, recommended, or .h5 to your file path. Training performance. The training accuracy reached 55% and validation accuracy stuck at 54%. The training loss decreased, good, but validation loss started increasing after initially decreasing. This pattern suggests early signs of overfitting. The model is memorizing the training data but not generalizing well to new questions. Let's fix the file saving issue. Train_model.py. Hashtag existing code. Hashtag train the model. Model.fit, x_train, y_train, epochs equals 10, validation_split equals 0.2. Hashtag save the model in TensorFlow format with proper extension. Model.save, static/model.keras, hashtag added.keras extension. Hashtag convert the...
Okay, I don't know why you're reading the code. Okay, now I expect it. Okay, 4856. Nah. It's not doing great. Headed. What on earth? Aero dumping weights. Let's actually move to of 3 mini. It's a reasoning model, but it's much it should be much faster as well. Okay, can you explain what's happening there? We do have now the model.js folder generated, but it's empty. There is a model.keras file in the static folder. I don't know why. I don't think it should be there. So we had an error as well. And if you can comment on why the model accuracy is pretty low, and comment on the loss as well. What's the loss doing over time? So what's, yep, doing 10 epochs, it's obviously will make sense.
Your model
to train
training
for
completed
longer.
without issues, and the model was saved as static/model.keras, which is expected in the new Keras native format. However, when converting to TensorFlow.js format, an error occurred because duplicate weight names, specifically kernel, were found. This usually happens when different layers, or multiple instances of the same layer, don't have unique weight naming, which the TF.js converter doesn't allow. Regarding model performance, the training accuracy is hovering around 55% while the validation accuracy is stuck near 54%. This indicates that the model isn't learning robust patterns from the data. The loss decreases during the early part of training and then plateaus, suggesting the model may be underfitting or that the architecture is too simple for the complexity of your data. In short, the saving issue is due to incompatible weight names for TF.js conversion, and the modest accuracy and loss behavior hint at a need for a more sophisticated model or additional data/regularization to improve performance.
Yeah, we can try scraping the site again. So we obviously talking about the bionichaos.com. If you haven't checked it out already, please go do so, and don't forget to provide your feedback. So we are scraping all the information on this site. We're doing that locally and training a chatbot that will hopefully show us something useful. And considering last time we did it quite some time ago, we might do the scraping again. Yes, the model is empty. Right, the model it generated is 9 megabytes. Okay, that should be manageable, shouldn't it? It's interesting considering the original data it's actually training on is only it's only around 1 megabyte. So maybe, and yeah, and from the accuracy it's having trouble to generalize. I can actually try and explain how is that happening. Is that actually doing anything? No. Hey, should we scrape again? Hey, can we actually review these 4 files? Give me a text-based response, don't include any code, and make it conversational. I want any specific issues found relevant to the previous discussion and the fact that the model accuracy is pretty low. It's like sitting at 50% and the loss is not going down when training. So can you give instructions as to how the code can be improved?
Here's a summary based on our review of the 4 files. The web scraper, scrape_bionichouse.py, is extracting tool data reasonably well, but consider checking if the text that becomes questions and answers is rich enough. If the data has a lot of short or imprecise descriptions, the resulting QA pairs may not be informative, which can hurt training quality. The content processor, content_processor.py, does a good job cleaning and organizing data, but you might improve how topics are extracted. It may help to refine the domain terms or tweak the regex patterns for more precise matches. If the content isn't parsed accurately, your training dataset might include noisy or misclassified information. The training data preparation, prepare_training_data.py, converts processed content into QA pairs and builds the vocabulary. One improvement is to experiment with different text pre-processing steps, for example, using stemming, lemmatization, or even pre-trained embeddings, so that your vocabulary captures more semantic meaning. Also, increasing stopword handling or more sophisticated tokenization might help in building a better representation. In train_model.py, the model is a simple LSTM-based sequence-to-sequence setup. The steady accuracy around 55% and plateauing loss suggest the model architecture might be too simple or the training data might not be very informative. Here are some suggestions. Try using a more advanced architecture, e.g., a transformer-based model or adding attention mechanisms, to better capture long-range dependencies. Increase the training data size and ensure the QA pairs are high quality. Experiment with hyperparameters like learning rate, dropout, or the size/number of LSTM layers. Consider integrating pre-trained embeddings, like glove, to provide richer word representations. Overall, improving data quality and enhancing model complexity should help the model learn more robust patterns.
Okay, that's interesting. Oops, didn't intend to do that. And weirdly enough, there's no way going back. Eh, uh, can essentially handle it can't handle all of it. Let's do 3.7 Sonnet, thinking we had the best luck with that one. Okay, so we have all the files, including what we scraped, and I'm focusing on the Python files. How can we improve the Python files, so the content processing, the scraping, the preparing, the training data, and actually training the model, so we have better performance than what shown above? If you can explain text-based continuous text conversational language as well, and start fixing the code. It won't let me finish. It's pretty annoying. And it's used only 6 references. The working set is 10 files.
I'll create and improve the Python files for the Bionic Chaos chatbot project to address the training issues and enhance conversational capabilities. Let's approach this systematically. Step-by-step solution. Create a robust scraping script to extract website content. Improve the content processing to better organize information. Enhance the training data preparation with advanced text processing. Fix the model training script to handle conversational language and avoid errors. Scrape_bionichouse.py. Create a scraper that fetches and processes website content. Import requests. Import JSON. Import logging. From BS4 import beautiful soup. From
How hard do you think it is to train the new chatbot?
Training a new chatbot can be quite complex. It involves designing the right algorithms, collecting and pre-processing data, and iterating on the model to improve performance. The difficulty really depends on the complexity of the tasks you want the chatbot to handle. Do you have any specific goals in mind for your chatbot?
So it will be essentially a chatbot for a specific website we are working on.
Absolutely. A chatbot can be designed specifically for your website. It can help with answering common questions, guiding users through your content, and even handling tasks like booking or customer support. If you have specific needs or features in mind, the chatbot can be customized accordingly. What kind of website are you working on?
Hey, can you actually look it up? It's called bionichaos.com. It's bionic and chaos.com with one C between the bionic and chaos.
I couldn't find a website at bionichaos.com. However, there's a YouTube channel named Bionic Chaos. You might want to check that out.
Well, yeah, the website has the same name.
It's possible the website isn't accessible at the moment, or it might
It
not
is
exist.
accessible at the moment.
If you're sure the website is up, you might want to double-check the spelling or provide more details. Sometimes websites might not be indexed yet. If there's another way
It
to
is indexed. It's been there for 2 years. It's the same name as the YouTube channel. So you were able to find the YouTube channel. Just try searching for the website again. It's bionicchaos.com.
I still couldn't find a website at bionicchaos.com.
I told you it's one C, not two C's. So it's Bionic Chaos with one C only, one letter C.
I still couldn't find a website at Bionic.
What? Yeah, this the correct URL. Can you try accessing it again?
Bionic Chaos is a platform offering interactive biomedical data tools and resources. Their website, bionicchaos.com, features various tools across neurological, cardiovascular, and other biomedical fields.
What's on the front page? Can you select the second best, most favorite tool on the front landing page, on the landing page?
I can't interact with or directly view live websites, but typically on Bionic Chaos, you'd find tools related to various biomedical fields. You might want to check the website directly for the specific tools available.
It's hopeless that way. Let's actually try. Hey, Gemini, you can share your screen. Okay, what do you see on the screen?
I see a web page titled Bionic Chaos with a list of tools on the left-hand side of the page. The tools include Hearing Aid Simulator, PaperViz, PDF Extractor, Procedural, Myoscope, SpectroWave, Boyd's Flocking, Mandelbrot Set, and PendleDraw. There are also navigation links for Home, About, and Contact on the top right-hand side. Is there anything else you would like me to describe?
Yeah, keep going. What do you see now?
Okay, now I see more tools on the same web page. They include Biomedical Fields Visualization, Jazz, Hexball, Myomock, Wolf, Sheep and Cabbage Puzzle, 3D Lego Builder, Dopamine, and Glassfill. Is there anything specific you would like me to focus on?
Okay, keep going and tell me which one's your favorite.
Okay, I see a few more tools, including ChatGPT Author, BreastMNIST, Webcam Filters, Essential Biomedical Tools for Learning and Research, EMG Hand Simulation Tool, Interactive Venn Diagram of AI Types, Datasaurus Dozen Visualization, Seizure Zone, Interactive 3D Brain Mapping Visualizer, and Mental Health Engineering. As an AI, I do not have preferences, so I don't have a favorite tool from this list. Is there any tool here you would like me to describe further?
No, no, just keep going over the tools. I keep scrolling down the page. Tell me what's unique about the tools that we went over so far. And yes, just make a guess. Guess which one will be, the most favorite, most successful tool.
Okay, I've scrolled down the page and see the following tools: bridging engineering in clinical language with AI, Ponzo illusion, joint time frequency scattering for seizure detection, Catapult, Pulsaviz, heart rate visualization, hearing test, and Graphit knowledge graph visualizer. It seems that many of these tools are related to medical visualization or research, with some interactive or game-like elements. Based on this, and if I had to make a guess, I would say essential biomedical tools for learning and research would be the most successful due to its broad range of applications. Is there any other tool you would like me to describe or discuss?
Yeah, keep going down the list. I scroll down the page.
Okay, I've scrolled down the page further and see the following tools: Cochlear Simulator, Eye Tracker, Real-Time Speech Visualizer, EEG Music, CardioBot, Rhythm Scan, Vision Impairment Simulator, Event-Related Potentials, ERPs, Advancing Neurotechnology, The Impact and Ethics of AI-Enhanced Brain-Computer Interfaces, and IEEG Review 16 Chan. Many of these seem related to brain activity or sensory input. Is there a specific tool that you would like to explore?
Okay, we keep going down the list, but also so far, which one stands out for you and why?
Okay, I see more tools now, including EEG spectrogram, ethical concerns of neural implants, IEEG spectrum visualization, 100 years of EEG, celebrating a century of EEG and its future potential, IEEG spectrum visualization with wavelet denoising, IEEG impedance, and synthetic EEG signal generator. Based on the tools we've discussed, I would say that 100 years of EEG stands out to me. This is because it appears to be a comprehensive overview that speaks to the history and potential of a large field, while the other tools seem to focus on more specific aspects of that field. What do you think?
No, that's a blog. Can you actually guess which ones are active web applications? The one you selected is a blog. So yeah, ideally we don't place blogs on the website. We have something more interactive.
You are right. I apologize for that. 100 years of EEG is indeed a blog, while most of the other tools are web applications. If we are looking for active web applications, I would say that the synthetic EEG signal generator stands out because it could be used for experimentation with various algorithms, devices, or theories, making it more interactive and useful. Would you agree?
Sure. Can we just keep going down the list? What else? What else do you see, and which one's your favorite so far?
Okay, I see the following tools now: EEG monitoring in ICU, the diagnostic limits and potentials of EEG, a critical review, EEG cross-coherence function, EEG data visualization, CardioQuest ECG scoring game, ECG synthetic signal generator, and ECG waveform feature extractor. Given that I am an AI and cannot have preferences, I do not have a favorite, but it seems that CardioQuest ECG scoring game is the most game-like tool and could be engaging for a user. Would you be interested in learning more about it?
So which one did you choose?
Since I do not have personal preferences, I did not choose a tool as a favorite. I only suggested CardioQuest ECG scoring game as a tool that might be more engaging for a user. Did you have one in mind?
I like your choice. We actually did you say the CardioQuest? Because we have another one that is actually where you can actually play against an AI, the CardioBot, as opposed to CardioQuest. In CardioBot, you can play an AI.
You're absolutely right. My apologies. I got the names mixed up. You chose CardioQuest, and the tool where you can play against the AI is CardioBot. Is there anything else you would like to discuss regarding the CardioBot tool?
Sounds like you want to wind up this conversation.
Yes, it does seem like we've reached the end of our exploration of the tools on this webpage. I am ready to conclude the conversation if you are.
No, there is more actually.
You are right. There are still more tools listed on the webpage. I see EEG monitoring in ICU, the diagnostic limits and potentials of EEG, a critical review, EEG cross-coherence function, EEG data visualization, CardioQuest ECG scoring game, ECG synthetic signal generator, and ECG waveform feature extractor. Do you want to go over any more tools from this list?
I scrolled a bit further. Are you happy to keep going? Yeah, I had a feeling it will time out, but it say yes, something went wrong. It didn't actually say time out or anything. It just went better. What's the adding emojis into the code for? Git train pipeline script. It sounds really good. Generating code, like yeah, Claude is definitely not the laziest out of all robots. I suspect it's doing too much as well. It seems like there is a problem in the train model Python file. It's I think you haven't finished generating it. Can you also explain? Can you continue? Can you fix it? Make sure it's complete and also explain it in continuous text, conversational text. It's
I
using
noticed
the
there's an issue in the train_model.py file. Let me fix that and provide a complete explanation. Import JSON. Import NumPy as NP. Import TensorFlow as TF. From tensorflow.keras.model.
isn't here in the train pipeline. Yeah, it's doing the scraping again. So might let it run. It might take some time, and then we see how the training went. Might have an issue. Can we interrupt? Can you give an overview of what these files are doing? A conversational text, and also fix any issues. There is a linting error in the content processor Py.
Overview of the Bionic Chaos Chatbot Training Pipeline. These scripts form a comprehensive training pipeline for a Bionic Chaos chatbot that can answer questions about biomedical tools and resources. Here's what each file does. Scrape_bionichaos.py web scraper that extracts content from the Bionic Chaos website. Content_processor.py processes local content files into structured data. Prepare_training_data.py generates Q&A pairs for training from the processed content. Train_model.py builds and trains a neural network model for the chatbot. Train_pipeline.py orchestrates the entire process from scraping to model training. Issue identified and fix. There's a syntax error in the content processor file. The isalpha method is missing its dot notation. Why?
Okay, just a quick conversational response. Don't change the code. Can you quickly check all the Python files and tell me if I just run the train pipeline Python code and expect it to complete the training and save the models in the correct folders, and also can I expect the training to be accurate enough?
Yes, if you run the train_pipeline.py script, it will execute all steps: scraping, processing, preparation, and training, as long as the prerequisites are met. It saves the model files in your static folder, including the TensorFlow.js version and the vocab mapping.
I didn't actually read that bit. Keep in mind that the training accuracy depends on the quality of your generated training data and the chosen hyperparameters. Hey, can you just in a conversational response without modifying the code and without generating any code in your response give me more details on the last sentence on the training accuracy and the hyperparameters? So that's O3 Mini. Still a reasoning model, but
The overall training accuracy will depend significantly on factors like training data quality, the variability in your QA pairs, and the alignment between your vocabulary and source texts. The hyperparameters, such as a 10-epoch training scheme, a batch size of 32, and a learning rate of 0.001, are reasonable starting points that help prevent overfitting, with dropout layers and early stopping added to the mix.
okay, so we scraped this side. Didn't produce a valid model. What? Hey, can you just explain this in conversational text without modifying the code?
It looks like while the training step ran and produced a trained model, the pipeline didn't find the expected TensorFlow.js model file, i.e., the model.json in the model_js directory.
Surprisingly, the chatbot is working. How do I replace a radiologist using this website? It's actually working pretty well. Well, it's
Bridging
working.
engineering and clinical language with AI. Learn how AI, particularly ChatGPT, can bridge the gap between biomedical engineers and clinicians, ensuring that everyone is on the same page when developing healthcare tools, clinical tools. And 35 more tools. Try refining your search to see specific tools.
Hey, can you give me a specific example of a biomedical imaging tool? Does this response make any sense? Found 39 relevant tools. Okay, it's not working that great.
Bridging engineering and clinical language with AI. Learn how AI, particularly ChatGPT, can bridge the gap between biomedical engineers and clinicians, ensuring that everyone is on the same page when developing healthcare tools, clinical tools.
Yeah, it's not answering the questions directly. So that's not great. You might have to continue this next door. Yeah, the yellow lizard is becoming hungry, so I have a chance of winning. Just can keep starving it. Okay, now it's faster, but now I can eat it, I think. Yeah. Oh, come on. Yeah, we won. Okay, I'll see you next time. Don't forget to check out the website, and we'll continue training chatbots and improving a hearing aid tool. Let me know if you have any special requests. This could be clickable stuff. Yeah, it's weird. It's giving links from the website, okay? Well, by the way, they reached 5,000, a whopping 5,000 watch hours on the YouTube channel. So thank you for watching. We could actually use some more comments, more interactions. Let's do chat quickly. Yeah, this bit had this problem before. What's up? Yeah, we have all three mini high, which we do not have in GitHub Copilot. and it's taking forever.
This training pipeline script is well structured and modular, allowing you to run individual steps of your chatbot's training process while ensuring all prerequisites are met. If the model file or vocabulary mapping is missing after the process, the script logs appropriate errors, prompting you to verify the corresponding parts of your pipeline, especially the model training and saving routines.
Okay, but so this code gave me the errors that I shared earlier. So can you comment on that?
Yes, based on the errors you encountered, here's what likely went wrong and how to fix it. Breakdown of the errors and fixes. GPU not being used.
Was was that that's some sort of older model? Yeah, it's 4.0 in the chat. Hey, can you do again the O3 mini high?
Even though the training appears to run with epochs and losses logged, the model isn't being saved in the expected location or format.
Anyhow, we'll have to go over it separately. Yeah, we have this paper visualization as well. This is all dynamic. You can load your text of your paper. It will give you statistics on the paper, word count, pages, authors, blah blah blah, affiliations. Venn diagram for the topics, but the most useful I find to be this research knowledge graph. It will be breaking it down based on colors, structure, method analysis, finding. Yeah, it's weird. This makes sense. And condition. So the methods use diffusion, MRI, and synchrotron. The structure. Okay. Analysis. Tractography. Structured tensor. Okay. Research timeline. So this was what was done, and topic distribution. So it's talking anatomy was mentioned this many times. Then we have imaging methods, analysis methods. So yeah, in theory, you could just place your text, paper text in this window, but yeah, the couple papers I tried it with only really works with this one. I'm showing you the abstract. Now I think we have this PDF extractor, which is, again, you can load any PDF. Oops. And it will separate the text and the images. You can download them separately if you like. Or zip of all the images and download the text as a text file. And it gives you a text preview. How good is that? Go check it out as well. And we're still working on the hearing aid simulator. We just released a video showcasing how it is working so far. There's a reason why it's called a simulator, so don't use it as a hearing aid. Well, yeah, it's not quite there yet. And there's quite a few tools on EMG that we added to the site. You can change a few parameters, baseline noise, flex, intensity, you can disable auto scaling. Some people don't like auto scaling. And flex with your mouse in this case, because we had another similar tool that's actually using your mouse. So it's using the touch screen or mouse to simulate. Again, it's a simulator, it's not real EMG, but it's indirectly measuring EMG of your finger, because currently I'm moving the mouse. You can see it's moving on the screen. And the EMG is being simulated accordingly to the movement. It's actually quite nice because it's working also outside the canvas. And you can change the static muscle contraction as your baseline, essentially. Go check it out as well. Yeah, I'll leave you with the simulator. I'll see you later. Bye.